Right. Very good morning to dear students. At the outset, I will congratulate all the students of your TYBSc to complete your second year course and came to the TYBSc with higher grade. I will also give you the best wishes to complete your graduation during this academic year 2020-21. This is the very first day of our academic year 2020-21, and first of all, in the very first lecture, we are going to study what is the syllabus pattern of your examination and what are the criteria for the passing for this TYBSc academic year 2020-20. As all of you know, our college is the autonomous college. We have the 60-40 pattern, which is the same pattern as in the previous year. So let us start first with the which courses you are going to study in this academic year 2020-21. So you have the 60-40 pattern just I have told to you, and you have the paper first. Paper first is of the physical chemistry. Which of the course code is UGCH 501, which is for the semester 5. And for the semester 6, the same code will be the UGCH 601. This is for the semester 6. Then paper second is of inorganic chemistry. Which of the course code is UGCH 502 for same 5 and UGCH 602 for same 6. Students, all of you know that in the previous year of FYBSc and the FYBSc, there is no initial specialization of the syllabus. That is the combination of all the subjects were there. That is, suppose physical chemistry section unit 1, inorganic is the unit 2, organic is unit 3. But now this coming current year academic year TYBSc, there is all papers are as per the specializations. That is why paper first is of the physical. The course code indicates UGCH, that is the undergraduate, U means undergraduate. Then C for the chemistry, CH for the chemistry, 5 for the same 5, and 01 is the paper 1. In the same manner, UG means the undergraduate, CH means the chemistry, 6 means semester 6, and 1 is the 01 is the paper first. Likewise, paper 2 is the inorganic chemistry. In that, UG states that undergraduate, CH means chemistry, and 5 means the semester 5, and 202 is the paper 2. And for semester 6, the same code will be the UGCH 602. That is undergraduate chemistry, semester 6, paper 2. The paper third is of the organic. The course code is again same pattern, UGCH 503, and UGCH 603, same 5 and the same 6, and paper 4 as per the specialization again is analytical. That is paper 4 UGCH 504 and UGCH 604. This is the course code for all the theory examinations. The same manner, these are the major subjects. These are all the major. And the applied component is paper 5. That is regarding the drugs and the dyes. So, friends, the paper second is the inorganic chemistry. That is, I am going to teach you. Now, as per the 60-40 pattern is concerned, 60 marks is for the theory and 40 marks for the internal evaluation work. And each head we must have the 40% passing. That means if student want to pass in each paper in each semester year, they must have at least got the 24 marks out of the 60 marks in theory, and the 40 marks is the internal evaluation. In that, it may be the 20 marks for the online examination and 20 marks for either assignment, for the project, for the any quizzes. The internal work can be come in that category. In that also, you must get the out of the 40, 50 marks must be required for the passing. Now come to the our syllabus now. Paper second is the inorganic. In addition to the 50 marks theory, there are all the sections must have the practical session also. And practicals will be there for the separate passing. So now we start actually our syllabus. I am going to teach you the inorganic chemistry in this academic year. So many of the students are knowing me during the practical sessions for my particular batch. Now come to the course code UGCH 502. Now, in this totally 4 units are there, and out of the 4 units, I am going to teach you the unit 3rd. In unit 3rd, there is the chapter chemistry of inner transition elements. This is a very big chapter which has the weightage of the 15 lectures. And unit 4, we have the some selected topics are there. Each topic have the 5 marks lecture weightage. The 3 chapters are there for each 5 lectures. Now, regarding the first chapter concerned, chemistry of the inner transition elements, this whole chapter have the 15 lecture weightage, and that's why out of the 60 marks, this chapter has the 15 marks weightage. It indicates that this chapter covers 1/4 of your syllabus as well as 1/4 of your marking weightage for the examinations, and that's why this chapter is very important from the your examination point of view. Now, what the remaining chapters are there, that I will show you when we start the actual unit 4th. Now, in this chemistry of the inner transition elements, what points we are going to cover? The first one is the two different series, you know. Two different series of these inner transition elements. After that, we are going to study the electronic configuration of these elements. And then once you know the electron configuration, based upon that, we are going to study the different properties. The first property is the oxidation state. Second property is the magnetic property. Then third property is we are going to study the lanthanide contraction. And its consequences. Then fourth property we are going to study, that is the color. Fifth is the spectra. And sixth is the ability to form complexes. So once you know the electron configuration, you can easily identify, easily study this property very well. Then after that, once this part is over, we have to study the nature of the occurrence. So occurrence and extraction. Occurrence and extraction of lanthanide. How the lanthanide occur in the nature, and from these different ores, how these lanthanides can be get separated from the ore. So for that, we have to study the two different techniques or the methods for separation of the lanthanides. The first one is the ion exchange method. And second is the solvent extraction method. Both the techniques we have to study with respect to the what are the principles of this method, and then we have to do the derivations of the equilibrium constant here, and then lastly, what are the applications of the lanthanides in a different fields. So this is the syllabus, it's a very vast syllabus, and that we are going to cover here in this particular chapter. So we will start out the first part. Without wasting the time, we will first go to the introduction part. Now if we see the periodic table, how many groups are there in periodic table? Can anybody tell? Yes, all of you are familiar with these things, that there are the 18 vertical columns are there. And that 18 vertical columns are called as the groups or the families. In the same manner, there are how many horizontal rows are there? So there are 7 horizontal rows, and that horizontal rows are called as the periods or pyramids. So this total 18 vertical columns and the 7 horizontal rows constitute how many total elements are there in the periodic table at present? Can anybody knows? Very good. Someone has told these are 180 elements are there. So nowadays, in the periodic table, total 180 elements are there, and they have arranged in a particular group for the period as per their physical and the chemical properties. Each element has its own atomic number and the atomic weight. So who have designed this modern periodic table? Anybody have the idea? So in 1871, the scientist Mendeleev have designed this modern periodic table. So total 18 vertical columns are there and 7 horizontal rows are there. Now we are going to arrange the basic lecture here, because starting the actual series of the inner transition elements and their position, we must know what is their position in the periodic table. So there are 18 vertical columns are there. Groups are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So here group 1, and suppose starting from the atomic number 1, first period hydrogen. Then at the end we have the helium is there in the group 18 with atom number 2 years ago. Then next will be the lithium, atom number 3, then we have the beryllium 4. Then here we have from the group 15 here we have the boron. Number 5. Then you have the carbon 6. Then nitrogen 7, oxygen 8, 9 fluorine, and then neon 10. Like that, the members are arranged here. So this is the second period, which again the short period. First period contains 2 elements. Second period contains the first period contains 2 elements. Second period contains 8 elements. Then third period starting from the sodium atomic number 11. Then we have the magnesium atomic number 12. After that we have the below the boron we have the aluminium 13. Then silicon 14. Then phosphorus 15, sulfur 16, chlorine 17, and then argon 18. Like that, the group period third will be over. So third period also contains the 8 elements. That indicates that first period contains only 2 elements, and the second period contains only third period contains 8 elements, which contain the short period. So there is no physical separation here between this and this here. Remain starting from the continuous way. After that, here the 19 is the potassium and calcium is the 20. And here is the first transition series starting from the scandium 21 to the 30. That is the up to the 12 year, 10 elements are there. So scandium to 30 zinc. So here many elements are there like scandium, then other titanium, vanadium, chromium, Mn, Fe, CO, Nr, Cu, and then zinc. and after that here 31 will be the gallium like that, and last end argon after that we have the 36. So here also we can write the element boron, element gallium, carbon, silicon, germanium, nitrogen, phosphorus, arsenic, or oxygen, nitrogen, sulfur, oxygen, sulfur, selenium like that, and then bromine 35. So here the first transition series starts. After that we have the hydrogen, lithium, sodium, potassium, then we have the rubidium. We have the rubidium, then we have the cesium, we have the francium. So here atomic number 37, then we have the 55, and after that we have the 70, 37, 55, and then we have the 87 like that. In the same manner, after rubidium, calcium will be there. For beryllium, magnesium, calcium, we have the strontium, and then we have the barium. So elements are adding there here. Likewise here 38, we have 39. 39 will be the for titanium, zirconium, vanadium, tantalum, and so we have the yttrium. So rubidium, strontium. After that we can use the. Then we can go here by adding these elements to the A. So last element aluminium, then we have the krypton, then we have the atom number 54 xenon, then 55 cesium, and then beryllium. So 38 to 48 here, 48 aluminium. First transition series start, second transition series start. After barium we have the lanthanum, which have the 56 barium and then lanthanum 56. Now our study comes start here now in case of the inner transition elements. Now let us see here with attention. The first period is the 2 elements, second period 8 elements, third period 8 elements, fourth period contains 8 elements, fifth period contains 8 elements. Now we will start the first, second, third, fourth, fifth, sixth period starting here. If you see or you observe the periodic table, which is the modern periodic table, here after lanthanum, the element must be in the fourth period is the 58. That is cerium. But in the periodic table, if the cerium is there, no, cerium is not placed there. But instead of that, there will be the hafnium is there, which have the atomic number 72. That indicates that from the 58 to the 71, the elements are there where that elements are placed. After the hafnium, here will be the mercury, will be the 80 again. And again the 81 to the xenon to the radon. 84, 86 will be there. Then come to the seventh period. Seventh period is the francium. And here after francium we have the actinium here at the 89 here. And here will be the after 89 the elements with the 104 will be here, that is the rutherfordium. Then question arises, where the element from the 90 to the 103 goes, where that position will be there. The same question arises here in case of the 6th period. And then here will be the last element in the 118. Friends, follow if knowing these things very well. You go to the last years. Then this 7th period was the incomplete period. 10, 20, 10 years back, you see only 4 to 5 elements are there in this group in 7th period. But now this period contains 32 elements. So every year new discovery is going on, and now this 7th period is now totally filled by the elements. So against 1 is the last element is there. That is the atomic number 118 that is discovered, and 7th period is completed. So my question arises here that where these elements are there. Now if you see the group 1 and the group 2, these are the strongly electropositive elements, and that's why they are called the F block element. They are placed at the extreme left of the periodic table. Then from group 13 to the group 17 you can say. These are the strongly electronegative elements are there. And that's why these are called the P block elements. They are placed the extreme right of the periodic table. And last group is 18. Initially the group was called as the 0 group element. Now it is called as the group 18. Initially nomenclature was also there differently. First day, second day, third day, fourth day, fifth day, sixth day, like that. 7th day. Then here first day, second day, like that. Third day, fourth day, fifth day, like that. But there after it was the 8th. But now as the group 18 are there, as per the numbering they are named as a group 1, 2, 3 like that. So last is the group 18, that is called the noble gases or the inner gases. Initially it was called the inner gases, and now the name has been changed because these elements are now neither remain the inert, they are very chemically reactive, and that's why the term inert gases is replaced by the noble gases. Now between the group 2 and between the group 13, there are the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups are there. So this group 3 to group 10, these are called as the elements are called as the D block elements. In other words, they are called as the transition elements. So group 3 to 12 constitute the transition element for the D block. So depending upon the differentiating electrons coming into the particular shell or the orbital, these are called the F block, they are called the P block, they are called the D block. Now the D block elements are called as the transition elements. So why the elements are called the transition elements? Because these elements show the transition from strongly electropositive F block metals to the strongly electronegative P block non-metals. And that's why these elements are called as the transition elements. Now there are 4 different series of the transition elements are there. The first transition series, second transition series, third transition series, and the fourth transition series. The first transition series starts with the starting from the scandium to the zinc, from number 21 to 30, and that is based upon the filling of the 3D orbitals. So 3D orbitals start filling in the scandium, and that ends in the zinc here. So 3D1 to 3D10 in the configuration. And that's why they are called the D block element, first transition serif or the 3D serif element. The next serif starts from the yttrium, then yttrium to the cadmium, atom number 39 to 40. Again 10 elements are there. So vanadium, tantalum, chromium, manganese, iron, cobalt, nickel. So SCTRG5. Then third serif starting from the lanthanum 57 here to the mercury 80, and lastly from the actinium to the this element. So likewise in each serif there are the 10 elements are there. So total transition elements here these are the 44 depending upon the 4 transition serif. All the pairs now completed pairs. So this is called the transition serif. Now what left here? That is our now study that we are going to study. So here, if you see here, the depending upon or based upon the electronic configuration you have studied in the previous year, that elements in the periodic table are classified into 4 different series, 4 different classes. The one is the normal and representative elements. Which are called the F and the P block elements. That means they constitute the group 1, group 2, group 12, group 13, 14, 15, 16, 17, and 18. The P block elements are also called, the noble gases are also coming in the P block categories. Then the second category is of the transition elements, which have the group number 3 to group number 12. And third category is the inner transition elements. What is the inner transition element? So they have the inner transition element. Now we are going to study in this category. Now see here, lanthanum 57 is there, and element is the hafnium, which have the atomic number 72. Then lanthanum have the electronic configuration in terms of the noble gases here. Lanthanum 57 is coming after the barium is xenon 4F0 5D1 6F2. So instead of the writing the configuration in 1F2 2F2 2P6 3F2 3P6 3D10 4F2 4P6 4D10 4F14. If you count the number of electrons here, 4F14, 4F0 configuration is 4F0. So 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18, 28, 30, 36, and then 4 plus 6, 10, 18, 28, 30, 36, and then 46. So 2F2 to P6, then 3F2 to P6, 3D10, 44, 10. Okay, then 4F0, 5F2, 5P6, and then 5D1 here is there. So now count here, we got the 46 here, then we got the 48, 48 and 54, then 55, 5D1 and 2 electron and F orbital. That's called the 57. So instead of writing all these things here to this 54, I have write the configuration of the xenon in short. So why this xenon is written here? Can you tell? Why instead of all this configuration I have written as a xenon? The simple reason is that xenon is the noble gas. and noble gas have the stable configuration of NF to NP6. Each element, if tried to achieve this configuration, which is the stable, some can lock the electrons, some can win the electrons, and some can share the electrons to achieve this configuration. And that's why we are writing this configuration in terms of the noble gases. Otherwise, you remember this thing, that why we are writing the configuration in a noble gas, because it is the most stable configuration which will achieve the stability. So xenon is at number 54 here. So 480, 5D1, 6F2, that is the lanthanum. So after lanthanum, the next element is the cerium, which have the atomic number 58, which have the configuration. Now these elements are called as the, starting from the lanthanum to the cerium to the atomic number 71 lutetium. These elements are not written here, but they are placed the main body of the periodic table. So they are called as the first series of the inner transition elements. The inner transition elements are classified into two different series. Which series? The first one is the lanthanide series. So as there is no place to accommodate these electrons in this periodic table, these elements are placed below the main body of the periodic table. And the similar properties starting from the, after the lanthanum 57 here 58 cerium to the 71 lutetium. After that lutetium, the element coming with atom number 72 is the hafnium here. In the same manner, after 87 and the 88, after actinium 89, we have the thorium 90 not placed here, but it is placed the main body of the periodic table. And then that is placed the here lawrencium and the 103. And after that, the element with the 104 come here as the rutherfordium. So these elements have the same properties, similarity in the properties, while these elements have the similarity in the properties, but they are placed below the main body of the periodic table, and they are written. After that, each elements are coming in this category. So this is called the first transition, inner transition series, and second inner transition series. Now, can anybody tell how where the elements are located? Now, I have shown completely the brief history of the periodic table. So, the S block, P block, D block, and here main zero is the F block elements are here. 4A block and the 5 block, depending upon the differentiation. Now, my question is, where these elements are lies? Where the first inner transition series of the element lies? Who can give the answer of this question? In which group and which period? So, if you see here, exactly below the group 3, the number is the lanthanum 57, and main body of the periodic table, after lanthanum, here we are starting the 58. So lanthanum, then cerium to the lutetium, all the elements are placed in the same group where the lanthanum is placed, that is barium, after barium. And then in which period are there? So first period, second period, third period, fourth period, fifth period, sixth period. So first period, second period, third, fourth, fifth and sixth period. So lanthanides are placed in a sixth period. And which group? The group is the third group. So I should remember that this is the position of the lanthanides in the periodic table. That lanthanides are placed in a group third and then period 7. In the same manner, second inner transition shape starting from the actinium 89 here, which belongs to the group third again. And then we got the thorium to the lawrencium. The protein elements are there, which are the main body of the periodic table, having similar properties. That's why, again, the elements are placed in a which group and the which period? The answer is the group is again third group, and period is now 7, not the 6th, because 6th we already completed here, and 7th period here we are starting here. So 7th period is the actinide. So now we are going to study in detail this inner transition series because it is a part of our syllabus. If we see here, the barium is not the, it is the group 2 element, it is not the trans element, it is not the inner trans element. Lanthanum, it is not the lanthanum is actually coming in this transition element, transition series. Actinium coming in the transition element. But then also these two elements are included here in this type of the series. So now you have our idea, the basic lecture, first lecture, the basic lecture, to what are the type of the elements in the periodic table. So all these groups we have studied, all the elements we have studied, which are arranged as per their atomic number, atomic weight, and they are categorized into the same groups based upon the same physical and chemical properties. So this is based upon the modern periodic law, which is the backbone of the inorganic chemistry. Can anybody tell the modern periodic law, which is behind this modern periodic law? We have given this periodic law, and what is the statement of this periodic law? So this I have told in the starting point that periodic table, modern periodic table is given by the Mendeleev in 1871. He defined. Before that, many versions of the periodic table were suggested by the many different scientists. But the most accepted and the widely distributed table, which is widely used all over the world, is the modern periodic table designed by the Mendeleev. We are given the periodic law. So initially, these elements were arranged based upon the atomic weight concept, and that is why at that time the periodic law was stated is like that, based upon the atomic weight. The properties of the elements, properties of the chemical elements are the periodic function. The term periodic function is very important here. The properties of the elements, chemical elements, are the periodic function of their atomic weight. That indicates that as the atomic weight of the elements are changed, the periodic properties also, will depend upon the atomic weight also change. But since then, the many research was going on this particular concept of the atomic weight, and finally it was found that it is not the atomic weight, but the atomic number is the property. The atomic number is there, which is the main base of this periodic property. And that's why the law which was there based upon the atomic weight, that was modified, and then it was restated that the properties of the chemical elements are the periodic functions of their atomic number, not the atomic weight. And since then the elements were then arranged based upon each group based upon the atomic numbers, not the atomic weight. So these are the two statements which of the periodic law. And then again, when the term electronic configuration come into picture, this periodic law was the modified as a modern periodic law. And this modern periodic law states that since electronic structures of the atoms and the elements can be changed periodically, this from the modern periodic law. Since electronic structures of the atoms and the elements can be changed periodically, the properties which are based upon that also tend to vary periodically on their atomic numbers. That's why the modern periodic law based upon the atomic number and the electronic configurations. So this modern periodic law you always keep in your mind, because it is the backbone of the inorganic chemistry, and all the elements, how many elements are there in the periodic table, just I will ask you, that is 180 elements are there. The 180 elements which are now present, that is classified based upon all this modern periodic law, which is called as the electronic structures of the atoms and the elements, which can be varied periodically with atomic number. The properties which are depend upon that also tend to vary periodically with their atomic number. Now we are going to study these two different series of the elements, of the inner transition elements based upon that. So two different series that we are discussed, inner transition elements. Which are the inner transition series? First one is the lanthanide series. And second is the actinide series. Now lanthanide series is arises, this series constitutes the 14 elements. Which 14 elements? Starting from the cerium, atomic number 58, to the atomic number 71, that is lutetium. So this, what is the position? It is belonging to the third group and sixth period. The atomic number of the barium is the 56, and after that lanthanum comes 57, which are the configuration xenon 4f0 5d1 6f. So here electrons are present as the 4f0 here. So no electron of 4f6, while the electrons in a d is the 1 and the 2 electrons are in the s orbital. After that, the cerium which are coming, that is atom number 58, have the configuration xenon 4f1 5d1 6s2. That means 4f orbital starts filling from the lanthanum and to the cerium 4f1. Likewise, the last element lutetium at atom number 71 have the configuration xenon 4f14 5d1 6s2. Just indicate that 4f orbital is completely filled by the electron. Now, in case of the lanthanum, the f electron starts filling in the polar orbitals, and in tritium shell is completely filled by the electrons.